Okay, lesson 6.2 is all about solving quadratic functions by graphing. Remember, anytime that we are solving, we're trying to find a solution or where we can make the function correct. So normally we're given a function in standard form. So we have our f of x equals ax squared plus bx plus c, and we would graph that to look like one of these graphs down here. And we know how to do that from 6.1. Now anytime we want to make it an equation that we can actually solve, we're going to see these as 0 equals ax squared plus bx plus c. Then in this case, where 0 is, 0 we're treating like our f of x or like our y. So the only place where 0 would be is where y is 0, which is right along the x-axis here. So if we want to make it true so that 0 equals our function, then it's going to be all the points that are along the x-axis. Or should I say where the parabola intersects the x-axis. So in this case here, we can see that it intersects only one place, right at the vertex. So that's why we say quadratic functions can have one real solution if the vertex is on the x-axis there, two real solutions if it crosses the x-axis twice, or no real solutions where, as you can see here, the parabola never touches the x-axis. So let's look at some examples of when these would actually occur. So if we have our function x squared minus 2x plus 1 equals 0, remember we're treating the 0 like y, or like our f of x. So we want to make a table that contains enough points where we can see the parabola and see how it works. So I always like to use -3 through 3 because it's centered around 0 here. So we can just plug in some of these numbers. So -3 squared is 9, minus 2 times -3 is -6, so it's minus a -6. Be like saying plus 6, and plus 1 there. So in the end, this one's going to become 16. Now similarly, we have -2. -2 squared is 4. Minus 2 times -2 is -4, so we're adding 4. And plus the 1 there becomes 9. -1 squared is 1. Minus 2 times -1 becomes a positive 2. And plus the 1 leaves us with 4. 0 squared is 0. Minus 2 times 0 is 0. Plus the 1, left with 1. 1 squared is 1. Minus 2 times 1 is 2. Plus the 1 there. Well, 1 minus 2 is -1. Plus 1 becomes 0. Move this one off to the side. 2 squared is 4. Minus 2 times 2 is 4. And plus the 1. 4 minus 4 cancel out. And we're left with just the 1. 3 squared is 9. Minus 2 times 3 is 6. And add the 1. So we're left with 4 here. Looks like this one is going to be off the chart. Chart doesn't go quite that high, so we'll start with some of these other ones. So where x is -2, say y is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll say that it's about right here. Where x is -1, we're at 1, 2, 3, 4. Where x is 0, we have 1, so that's going to be this spot right here. Where x is 1, we have 0. Where x is 2, we have 1. And where x is 3, we have 4. So it looks like this is the graph of our parabola. And as we can see, touches that x-axis only one point. Right there. So we say we have only one solution. We're not quite finished. We need to say that that solution is x equals 1. You need to say what your x actually equals to make this function true. So in this case here, we'd have to set x equal to 1 to make our left side equal to our right side, which is 0. So if we try that with another one here, in this case we have -x squared minus 2x equals 0. One thing to be careful on is this one, our a value is negative. We have a negative 1 in the front there, which means our parabola is going to be opening down instead of opening up. So just be careful on that one. Again, we'll use our standard -3 through 3 for our table. -3 squared is 9, and we want the opposite of that, because we have the negative out front. So we have -9. -3 times -2 is a 6. So -9 plus 6 is -3. Similarly here, -2 squared is 4, but we want the opposite of it because of that negative out front. -2 times -2 is 4, so we get 0. So it looks like there's one of our zeros already. -1 squared is 1, and we want the negative of it. -1 times -2 is a +2, which leaves us with 1. 0 squared is 0, and -0 is still just 0. And if we want to minus 2 times 0 is still 0. So 0 minus 0 is 0. So it looks like there's another 0 for us. 1 squared is 1, and we want the negative of it. Minus -2 times 1 is -2. So we have -1 minus 2 is -3. Now at this point, you should be able to see a pattern. We have our -3, 0, 1, 0, -3. So at this point, we don't need to do the rest of them. We can just say that our x is -1, 2, 3. We have -1, 2, 3 as our y. Similarly, where x is -1, 2, we are at 0. Where x is -1, we are up at 1. Where x is 0, we're back to 0. And where x is 1, we're at -3. Now, if you didn't quite notice enough points here to make a parabola, you have to keep going with these in either direction. Either keep going positive here, or maybe keep going negative, like -4, -5, make some other ones, until you have enough to comfortably make this full parabola. Once we have our parabola here, again, we can notice that it hits the x-axis twice. So we have two solutions. In this case, we have one where x is -2 and one where x is 0. Now we can write it this way, kind of separated, or we can just write all as one, x is -2, 0. Put a comma there to show that there's two different possibilities. It can be the -2 or it can be the 0. Both will work. Now notice how it isn't parentheses -2, 0. That's a coordinate point. Remember, that's our xy value. We do not want to use that to describe our solution set. This is our solution set, where x is -2 or x is 0. Got one more example here. So again, we'll use our standard numbers. -3 squared is 9. We want the opposite of that. It's -9. -3 times 2, -6, and minus another 2. Looks like this one's going to become -17, which is definitely off the chart. -2 squared is 4. We want the opposite of that. -2 times 2 is subtract another 4, and subtract the 2 at the end. So that one's going to be -10. Also kind of off the chart. -1 squared is 1. We want the opposite of it. Plus 2 times -1 is -2. And subtract another 2 here. This becomes a -5. 0 squared is 0. Plus 2 times 0 is 0. And subtracting a 2. Left with a -2. 1 squared is 1. And we want the negative of it. Plus 2 times 1 is 2. And we're subtracting 2. Looks like these ones cancel out. And this one becomes a -1. Going on with our 2, we have 2 squared is 4. And we want the negative of it, so -4. 2 times 2 is +4. Oops, +4. And we subtract a 2 at the end. +4 and the -4 cancel out. So we're left with just the -2. And if we're looking at 3, we want -3 squared is 9. Plus 2 times 3 is 6. Minus our 2. we have negative 9 plus 6 minus 2. That's going to give us our negative 5. So in this case, we'll not use those ones because those are off the chart. We'd say where x is negative 1, we have negative 1, 2, 3, 4, 5 as a point. Where x is 0, y is negative 2. Where x is 1, we're at negative 1. Where x is 2, we're at negative 2. And where x is 3, we're back to negative 5. So it looks like this is our parabola in this case. Now again, in this case, we can notice that it never actually crosses our x-axis here. So in this case, our number of solutions is 0. There are no solutions. So if we had to write that out, we'd say x equals no solutions.